Welcome to this explainer. Today, we're diving straight into a massive shift happening right now in how we build AI applications. We're moving far away from those old, clunky dependency managers and closed-source models and stepping into a lightning-fast, highly optimized open-source ecosystem that is literally changing by the minute. Here's the roadmap for today's explainer. We'll start with a spiritual journey framework, look at the DeepSeek disruption, break down fine-tuning, explore the UV package manager, and wrap it all up with light LLM. All right, part one, the spiritual journey, focusing on discipline and focus. We're starting with a beautiful framework inspired by a recent community update about completing Umrah. Think about the physical and spiritual process here. It requires absolute immense focus. You have to enter this state of Hiram at the Miqat boundary before you even arrive. Then, exactly 7 circumambulations for Tawaf. After that, the sa'i between Safa and Marwa. And finally concluding with the Halq, or haircut. There's zero room for cutting corners, no stitched clothes, no perfumes, just unbroken focus. And honestly, this unyielding sequential discipline, that's exactly the mindset you need when architecting flawless, modern AI systems. Moving on to part two, the DeepSeek disruption and how it completely changed the AI game. So, speaking of discipline, let's talk about the global industry news that literally changed the rules overnight. Look at this crazy contrast. DeepSeek drops a fully open source, absolutely massive model, and it only costs them around $6 million to train. $6 million. Compare that to the billions, with a B, spent by the closed-source giants. I mean, this sent such a shockwave through the industry that it actually caused NVIDIA's stock to drop. It proved to everyone that, hey, you don't actually need a multi-billion-dollar supercomputer cluster to hit frontier-level AI performance anymore. And this leads perfectly into a brilliant point made by AI pioneer Andrew Ng. The big takeaway here, for everyday developers like us, the most profitable path isn't trying to compete in the massive horizontal model space. Leave that to the titans. The real gold rush right now is building highly specialized, vertical AI agents tailored to very specific industries and tasks. Which brings us to Section 3, understanding fine-tuning to customize these open models. If we're going to build these specialized vertical agents, we need to know how to heavily customize base models. And the great news is, thanks to techniques like PEFT and low-rank adaptation, or LoRa, you don't need a massive data center to teach a model new tricks. Get this, you can actually start fine-tuning with a tiny dataset of just 20 input-output samples. Literally, you could spend a single afternoon writing out 20 examples, and boom, you've reprogrammed a supercomputer to be an absolute expert in your specific niche. I absolutely love the analogy used in the source material for this. Think of fine-tuning as finally learning how to drive a car yourself. You have total independence, right? The knowledge is baked straight into your brain, or, well, the model's weights. On the flip side, if you're relying entirely on external APIs or RAG, where the AI just searches documents for answers, it's kind of like constantly calling your brother for driving instructions at every single stoplight. Sure, it works, but man, it's slow, annoying, and you're totally dependent. Let's look at how incredibly simple this has become in practice. Let's use the Google Gemini API as an example. You literally just pick a base model, feed it a structured list of at least 20 dictionary samples, just inputs and outputs, and then you hit the Create Tuned Model method. That's it. It generates a unique, fine-tuned model access key for you. You can train it to increment numbers, read specific types of medical scans, or even adopt a hyper-specific customer service persona. This is exactly how you build those vertical agents Andrew Ngo was talking about. Okay, Section 4, the UV package manager and why it makes Python lightning fast. So, to support all this fast-paced AI development, we need to upgrade our tooling. Enter UV. It just completely outclasses older package managers like pip, poetry, or conda. Because UV is written in Rust, which runs super close to machine code, it is insanely fast. It uses parallel downloading, meaning it grabs all your packages at the exact same time, making it up to 100 times faster than those old sequential tools. Oh, and it handles virtual environments right out of the box. Seriously, UV solves so many massive developer headaches. If you've ever wasted a Friday night pulling your hair out over a broken pip environment, you are gonna love this. It natively eliminates dependency conflicts using thousands of built-in resolution rules. But the absolute killer feature, global memory management. It caches a package globally on your machine exactly once and then just links to it across all your different virtual environments. That saves a massive amount of storage and makes spinning up a new environment pretty much instantaneous. And you know what else? It enforces best practices by default. You just run a single command, uv-initiate-package, and you instantly get a perfect industry-standard folder structure. It sets up your SRC folder for the code, and more importantly, it centers everything around the pyproject.toml file. That file basically becomes the ultimate control center for all your dependencies, custom scripts, and project metadata. All right, final piece of the puzzle. Section 5, LightLM integration for unified model access. Okay, so we've got our blazing fast UV projects set up, our finely tuned models are ready, but here's the massive bottleneck we hit next. Every single AI company out there, OpenAI, Anthropic, Google, they all have completely different SDK syntaxes. It used to be that developers wasted hours rewriting code just to test a new model. Like, if you wanted to swap ChatGPT out for an open source model like Llama, you had to refactor your entire application logic. Total nightmare, right? Well, LightLLM is the game changer here. It brilliantly standardizes the inputs and outputs of every single AI model into the familiar OpenAI syntax. Think of it as a universal translator for your app. You write your code exactly once using the standard OpenAI completion format, and LightLLM just magically translates it behind the scenes for over 100 different frontier models.
It is so beautifully simple in practice. Say you want to switch from ChatGPT to Gemini. You literally only do two things. Update the model name string in your completion.function and swap the API key variable in your .env file. That is the whole shebang. Zero other code changes needed. You can benchmark a brand new open source model like DeepSeek against a proprietary one in seconds without touching your core logic.
We have covered an incredible journey in this explainer today. We started with the unyielding structural discipline required for great engineering, moved through the explosive open-source disruption of DeepSeek, and saw how fine-tuning gives you total independence. Add in UV supercharging your workflow and LitLLM unifying your model access, and wow, the foundation is set. The barriers to entry have literally never been lower. So the only question left is, what highly specialized vertical AI agent are you going to build first?